Assalamualaikum warahmatullahi wabarakatuh. My name is AIMI binti Muhammad Aisyah. I will continue the presentation from the group before this, which is the sanitary system. I will explain about the maintenance of it. Okay, so the white box you can see is the problem in the sanitary system. So the first one is the problem in sewer roof vent. Second, foundation drain or sump pump. Broken house lateral. Sanitary sewer main. Deteriorated manhole. Storm cross section. Dry field drain. Roof drain connection. That is the problem. So the yellow box is for the testing. For each part of it, we need to check whether it needs maintenance or not. Okay, so a lot of it use CCTV, smog testing, and dye testing. So what is smog testing? I will explain about smog testing first. So smog testing, they will put a pump in here, and then the pump will release smoke. It will create and release smoke lah, and then the smoke will go through here. It goes through here. Okay. So let's say there is crack in here and then here. Okay, so the smoke will goes up here and here. So where the smoke goes up, there is crack or break, something like that. Okay. And then the second one is dye testing. Dye testing, it is similar to smoke testing, but it use water instead and dye. Dye is color. It doesn't matter blue, red or green, but it is color like food coloring. Okay, so they will put the dye in here, the color in here. So if let's say the color is not the water stays transparent color in here, water color lah. So that means there is problem around here. Maybe there is rock or maybe brick. Okay. And then there is CCTV. Okay. So for the CCTV, we know that CCTV use camera, right? So same like smog and dye, they will insert camera in here. So it is easier because they can see. There will be like a monitor that they can see whether there is break or crack or maybe root. Okay, or maybe separated joint. They can see that. Okay. So next, I will explain about the trap used in sanitary system. So there are a few types of trap, which is the P trap, S trap, and also the bottle trap. So it is based on the shape lah, basically. Okay. So the purpose to install the trap is to prevent any passage of air into a house through a pipe which has been clogged by dirty water or soapy water. Okay, so here is the waste in, and then the trap, the waste will stay here, and then the water will goes out. Okay, so this is how it works lah, trap. Okay, there will be water with waste goes through here, and then the waste will stay here. Okay, and then the water will just go out. Okay, so the waste will stay in here, and then we actually need to clean the trap. Okay, so why we use trap, right? Because we don't want any passage of air into a house. Why we don't want air into the house? Because this waste has bad smell. Okay, if we don't trap it, so the bad smell will just follow the water, and then the bad smell will go to our house. Okay, something like that. Okay, so the next part is the installation of the trap. Okay, so I have watched few YouTube videos. So I think after I watched it, I think the installation is not that hard because why I say that? Imagine you have like three part of pipe. This is the first one. Okay, then the second one, the trap, and then the third one. Here, okay. So what you need to do is you need to connect the first and the second one, right? And then you need to tighten this pin. Okay. So it's like you tighten screw or water bottle, and then after you done with that, and then the second part, and then the third part, and then you do the same thing. Okay, and here just to connect all three. So that's it from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad bin NORDIN and I will continue with the subtopic loss of trapped water seal. So in this subtopic, we will learn about self-siphonage, induced siphonage, compression or back siphonage, capillary attraction, and wavering out. So first, the self-siphonage. Because of the curved design, this frequently happens in wash basin and other tiny equipment. It's caused by a moving plug of water in a waste pipe. A partial vacuum is created at the outlet of the trap, causing siphonage. Air bubbles are drawn through the trap during discharge of the water, which act as a pump, drawing more water to flow out. So, to make all of you more understand about this, I will show you some video.
Reservoirs and traps are frequently depleted by siphonage. This is where an under pressure condition is created in the DWV piping and water gets sucked from the trap. Low pressure transients can happen, for example when a toilet is flushed into a nearby section of pipe. High pressure transients can also cause siphonage and even lead to sewer gas bubbling back through a trap which still contains water. Siphonage is a very common cause of trap seal failure and odor issues.
So next, self-siphonage and how to prevent. Self-siphonage is usually prevented by one or more of the following. First, make sure that the length and slope of the branch discharge pipe do not exceed those recommended. Second, a ventilation or anti-siphon pipe can be installed next to the trap outlet. Third, by connecting the trap outlet to a bigger diameter branch discharge pipe. Fourth, by correct design of sanitary appliance. And lastly, by fitting a resealing or anti-siphon trap to the sanitary appliance. Next, we have the induced siphonage. This is caused by the discharge of water waste from one sanitary appliance, pulling or siphoning the seal of a trap to another appliance connected to the same branch discharge pipe. This form of siphonage is most common in buildings where ranges of appliances are fitted or where it is necessary to connect several appliances to a common branch discharge pipe. The main causes of induced siphonage are poor system design, inadequate pipe size, or bad installation technique. So I will show you some video example. So this occurs where two waste traps feed into a common waste pipe. When wastewater is discharged into the pipe from one trap, as that water flows down the pipe, the air is drawn through the other trap. Both this form or siphonage are really design fault. So how to prevent this induced siphonage? Some ventilation of the system may be required if induced siphonage is to be prevented. First, as the appliance empties, Second, the pipe is filled with water. Then, it causing low pressure in the waist of the second appliance. So, pulling out the water from the trap. And then the water will discharging from appliance. So, next, compression or back siphonage. This causes when the water flowing down a stack changes direction at the bend which compresses the air in the pipes and forces out the trap water seal.
Example of back siphonage. Here is an example of back siphonage caused by a booster pump. Both buildings below share a common distribution main. The building on the right has a booster pump, B, which pumps water to a tank on top of the building. Backflow could occur as the booster pump draws pressure from the suction side of the pump, or in this case, the distribution main and the neighboring building on the right. Negative pressure occurs at taps on the building on the left, siphoning potentially contaminated water back down into the distribution main and the building on the right. Backflow could be more likely if the pump on the building on the right does not have a cutoff pressure switch for when pressure drops, or when the booster pump stops running. This back siphonage could be made worse because of the height of the building on the left. Point A would be the first to experience negative pressure and potential backflow. High elevation differences can greatly magnify the effects of low pressure, increasing chances for back siphonage.
Compression or back siphonage. How to prevent? Under these conditions, a hydraulic wave is formed and air at the base of the stack is compressed by water falling from above, thus creating air pressure in excess of atmospheric pressure. This pressure will attempt to escape through by any branch discharge pipe connected in the compression zone, thus blowing the seal of the trap and allowing fall air from inside the discharge pipework to enter the building. Often the displaced water will run back into the trap to form a seal, but continued blowing off the seal will cause a nuisance and allow fall gases into the room where the appliance is fitted. Compression and back pressure are prevented by not fitting small or sharp radius bands or having branch discharge pipes connected near to the base of a discharge stack. Correct practice is to fit large radius bands and to ensure inlet connections are not made close to the base of the stack. That's all from me, and NORDIN will continue the next load.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad ASSUFI. So, the capillary attraction. This is caused by a piece of porous material being caught at an outlet of the thread. So, porous material is a material that contains void, which is make it easy for liquid to pass through them, and the water will flow through the material and out of the water seal. So, the example of the porous material is sponge and paper. Capillarity is prevented by regular cleaning of the inside of the trap and branch discharge pipe. Capillarity is prevented by laying a loose mesh strainer into the waste fitting of the appliance to catch and retain loose porous strands which may be contained in certain type of wastewater. Wavering out. This is caused by a high velocity of wind passing over the vent pipe, which draws some of the air out of the pipe, thus creating vacuum out on the outlet side of the trap. The gust wind causes the water in the trap to oscillate until the water seal in the trap is broken. So how to prevent is fluctuating pressures caused by wind are best prevented by locating vent terminal position away from exposed location ensuring that a terminal grating is fed to all ventilating pipe. Resealing and anti-siphon trap. Trap water seals can be maintained by fitting either a resealing or anti-siphon trap. For all the anti-siphonage and resealing will require more maintenance than ordinary trap, and they are liable to be noisy. So the example for the anti-siphon trap is McAlpine trap, Gravatt trap, Econa trap, and anti-siphon trap. McAlpine trap. The McAlpine trap has a reserve chamber into which the water is forced when siphonage takes place. After siphonage, the water in the chamber falls and reseals the trap. Gravatt trap. The Gravatt trap contains an anti-siphonage pipe through which air flows to break the siphonage action. Econa trap. The Econa trap contains a cylinder on the outer into which the water flows when the trap is siphoned. After siphonage has taken place, the water in the cylinder reseals the trap. Next, anti-siphon trap. The anti-siphon trap has a valve on its outlet which opens and allows air to flow into the outlet of the trap, thus preventing siphonage. So that's all from me. Thank you.